Hi everyone, welcome to AWS Summit Online. We're so excited you're here. In this session, we're going to be talking about building serverless applications with infrastructure as code. And if you don't know what infrastructure as code is or you've never used it, don't worry, we're going to get everyone up to speed in a little bit. My name is Talia Nasi, and I'm a Senior Developer Advocate for serverless here at AWS. My job is to build serverless things and then teach the world about them. Before becoming a developer advocate, I was a test engineer for a few years. I worked at Visa, Forbes, and WeWork. I also have my Twitter handle here in case you want to contact me for more fun stuff. So today we're going to go through a few different topics. First, we'll talk about infrastructure as code, specifically how it relates to serverless. Then we're going to talk about what it means to be a serverless application and what that looks like. We're going to make a template reusable, and when I say template, that's what infrastructure as code is. And one of the huge benefits of infrastructure as code that we're going to talk about today is its reusability. So you're going to create a template and then you put it in different places. You can use multiple accounts, things like that. And then we're going to prepare for deployment, and then we'll actually deploy the application at the end and finish it off with a demo. So let's get started. When we say serverless, we mean it's the removal of server operations. And this is an important distinction for customers because it allows you all to focus on the building of the application rather than management and scaling of the infrastructure to support the application. And there's 4 tenets that define serverless as an operational model. Firstly, there's no infrastructure to provision or manage, which means there's no servers to spin up, operate, or patch. There's no physical or virtual container orchestration. Next, serverless applications automatically scale by unit of consumption rather than by server unit. And automatic scaling is a really big win because generally you create multiple MVPs and you don't want to build all of them out for scalability. Serverless also has a pay-for-value billing model, which means you only pay for what you use, not idle time. So if you have an idea that's not taking off, some of them can get expensive. So this means that you can experiment more. So let's say I have an idea for a new feature and Bob has a competing idea for a new feature. Bob and I can A/B test our features, and regardless of which feature has a higher conversion rate, it's not going to cost much. It's not going to cost a lot of money because you only pay for what your customers are using. Lastly, serverless applications have built-in availability and fault tolerance, so there's no need to architect for availability because it's built into the service. This is important because things will break, unexpected things happen, data centers have outages, there's earthquakes, spaghetti and meatballs can fall from the sky. So what do you do if the servers handling your project fall over? How do you know that all of your versions are in sync with all of your regions? Have no fear, serverless is here, my friend. So this all happens automatically for you with this built-in availability. And many times when developers are building their serverless applications, they start in the AWS console. And so what happens is you choose the services you want and then you connect them all. You build your Lambda function here, you choose what you want as a trigger there, you choose what you want as the destination. And so you can create all of the resources that you need right there in the console. And this is a really great way to learn. But the only problem here comes when you want to move your resources to different accounts, or you want to move it from one environment to another, or just somehow replicate what you've done in the console. And chances are you're not going to know exactly how you set up the resources in the first place or exactly what configurations you set. So to solve this problem, we're going to look outside of the console to something that's called templates. And templates bring us to infrastructure as code. Templates are a way to store our infrastructure so that it can be reusable. And so with infrastructure as code, you're automating this provisioning process. And so that means you're not going to go to the console, click on the services you want, create the resources from the console, etc. You're going to use a tool called SAM, which we'll talk about in a minute, and you're going to use SAM to deploy. We're going to instantiate infrastructure using configuration files. And so basically what this means is you have this template with all the steps and configuration for your application that you can use whenever you need. And this allows you to treat those configuration files as code. And what do you do with code? you version it, you put it in some kind of repo in either GitHub or code commit or something like that. You can deploy a version, work on it, and then merge a new version so you can roll back if you need to. So when you move to infrastructure as code, you do the same thing with infrastructure. So if something breaks and your infrastructure isn't working, well, let's roll it back, or let's try a new version, or let's move it over here to this other environment, but it's all packaged up and ready for you. And finally, this allows you to eliminate configuration drift through automation. So this is that classic, well, hey, it works on my machine shenanigans. So let's say you get paged one night because there's an incident for your mobile application. So you look at the logs, you identify the problem, you figure out what's going on, but in order to fix it, you need to update a specific configuration in production. So you make the change in production and you go back to sleep because it's the middle of the night. Although you fixed the issue, you've just created an even bigger divide between your staging and production environment because you didn't make the same change in your staging environment. Many times, staging environments are not the same as production because of changes made during incident management. And so this is called a configuration drift. So with infrastructure as code, rather than that shift in environments, you have one central authority that is this template, and then you push the infrastructure changes through. Now we have several infrastructure as code solutions here at AWS. The primary one is AWS CloudFormation. A lot of the other ones are built on top of that. The one that we're going to talk about mostly today is AWS SAM, AWS Serverless Application Model. And then there's also the AWS Cloud Development Kit, or CDK, which allows you to write a little bit more code. So you do have a lot of options here. Again, one of the IAC tools that AWS provides is called SAM, the Serverless Application Model. So this little guy is the SAM squirrel. He's the SAM mascot. And we do have a squirrel suit that our team wears on occasion. When I say my team, I mean everybody but me. I won't be putting on the suit, but these are my friends, James Bezic and Eric Johnson, wearing the Sam the squirrel suit. So SAM comes in two parts. The first is the AWS SAM templates, which we just talked about and we're going to see in the next slide. And so SAM templates allow you to version your infrastructure as code. The second is the AWS SAM CLI, or the command line interface. And this is a utility that you install on your local machine that helps you with local development, debugging, builds, and deployment for your serverless application. So let's go through these. This is what an example SAM template looks like. It is written in YAML, and you can see that there's a few resources that are being created here. So there's an AWS Lambda function, there's a DynamoDB table, there's an API. So you can see that I created the Lambda function. I added the corresponding IAM role that lets the Lambda function talk to the DynamoDB table. There's a lot of options when it comes to policies to add to your services, and these SAM templates simplify all of that for you. So you can change this to a write policy or whatever you need, really. And so what we're doing is we're creating an API from API Gateway. So your event source for your Lambda function here is this HTTP API. And you can configure these templates to add any AWS resources and create your application so that you have a lot of flexibility to build what you want. And notice that in just 20 lines, it creates a Lambda function, an IAM role, an API gateway, a DynamoDB table, and all the permissions that are needed for everything to connect. So with these 20 lines of code, this on the left becomes this on the right. So you have the Lambda function that's triggered by API Gateway. You have the DynamoDB table that stores all of the data. And what's already created for you is the permission for API Gateway to invoke the Lambda function. And so that happens automatically for you in SAM when you set API Gateway as the event source for the Lambda function. And then you added the policy saying you can only read from that table. So now we're going to go through the steps to create a serverless application. And the first thing you're going to need to do is install SAM, and you can do that with this link. You can go to s12d.com/SAM install, or you can use this QR code, but you are going to need to install SAM. Once you have SAM installed, the first command you need to run is SAM init. And when you do that, you need to fill out a few things. So first you need to choose what kind of template you want. And we give you some templates to start with. You don't have to build all of this from scratch. You can do a simple Hello World application like the one shown here. You can do a web backend, which we have a template for. We have a bunch of different templates you can choose from. And then you have to select your runtime. So you can choose Python, Ruby, Go, Java, .NET Core, or maybe you want to use a custom runtime. So you have a lot of options here. Then you have to choose your dependency manager if your runtime requires it. And then the result is something like this on the right. So you get the README with some instructions. You have the events that trigger the Lambda function, and then the Hello World folder with all the information about the Hello World function. And then you have the template YAML file, which is the SAM template that you will create all of your resources that we just saw. And so the whole goal of infrastructure as code is to make it reusable, right? And so if I redo something, I want it to be simple. I don't want to have to go through, making sure that all my configuration changes are there and stressing over that. I want it to be really simple. Why is that? Because in an ideal world, everyone would just test in production. And if you know me or have heard me speak before, you know how passionate I am about testing in production. But sometimes that's not an option, and your infrastructure team is not set up to test in prod. So you have staging environments or other test environments in place, sometimes a beta environment. So when we're dealing with serverless, the best practice is to have a developer account for each developer. And so you use the same template to do that. So your environments like beta, staging, production should all have their own account. And then there's also inherent security in this when you're saying that only folks who get to deploy to production should have access to production, right? And the same thing happens with staging. So that's one thing that you get out of this. And by breaking these out and using the same templates, you also ensure consistency across the environment. So this is great when, let's say you're onboarding a new developer and they're setting up their environment and someone gives them this thick book and says, okay, here you go. This is how you set up your environment. Like, that developer is going to be so stressed. And so it's going to be so confusing for them to go through all of the steps. But in this new way, you can just give them the template and say, hey, deploy this, and then you're done. And you have everything that you need. You have all the resources. When you make your template reusable, you're saying you want to use it regardless of which environment you're in, right? So in order to do that, you parameterize the template. You make it have dynamic values that change based on how you're approaching it. And there's a lot of different ways to do this, and we're going to talk about some of them. The first way is that we can parameterize your template to make it more dynamic, and this is through template parameters, and these are declared through the template itself that'll be passed into the Lambda function. And these are added or created at update or deploy, and you cannot change these. So they can be typed and validated, and they're stored on the deployment machine. This isn't where you want to keep your secrets. It's just where you want to keep your environment information. So is it dev? Is it staging? Whatever. It's for very simple things. It's just not for secrets or passwords. The second is environment parameters, and these are added at creation or update as well, and they're stored in open text on the console. So again, not a good place to store secrets because everyone with access to the account can see them, and they are dynamically referenced in the template, so you can grab them through code, but you can't change them. The next is the AWS Systems Manager parameter store and the AWS Secrets Manager. So these are very similar in how they work, and you can add these at creation, update, or runtime. These can be accessed in your code, so if it's something that you need to grab at every invoke, then this might be a good place to store them. The Systems Manager parameter store works for some resources, not all of them, but the Secrets Manager works with a lot more resources. And the final way is through app config. App config allows you to set configurations for your Lambda functions. We also have this really cool thing that we just launched called extensions, and this is really good if you want to change something a lot, but you don't want to call it every single time a Lambda function is invoked. The other way of parameterizing your templates is through functions and parameters. So CloudFormation has the idea of intrinsic functions and allows you to insert logic into your templates. And you can do some conversion like base64, you can substitute strings, things like that. So there's a lot of different ways that you can grab dynamic values as needed. And then you have what's called pseudo parameters. And this is where you can reference what region you're in, and you don't want to hard code that because sometimes you don't know. So you can use a pseudo parameter like AWS region, same with account number and all the rest of these. Okay, so now we have our template, we know what we want to deploy, and now we want to deploy it, right? So SAM CLI has this command called SAM build. And there's a lot of things that happen when you run SAM build. So first of all, you can build with native runtimes. You can also do a custom build using a make file. And so this gives you a lot of flexibility. And just to note, a lot of the runtimes are supported by containers. So if you do SAM builds -- use container, then you'll grab a container that's based on the environment that the Lambda function will run in and build that out for you. You can also pass a cached or parallel flag. And so the cached flag will say, hey, cache this build. So let's say I have 10 Lambda functions and I make a change to just one of them. When I do the build, 9 of them will be cached, but only 1 would need rebuilding. And so this makes the build much, much faster. You can also build in parallel and say -- parallel when you run, and it'll build them all at the same time. So this makes the local development much faster as well. You can also do omission if you want to omit certain files. So you do have a lot of flexibility here. You can mold this as you like. So when you run SAM build, it creates a separate folder and isolates each of their functions into their own build. And it takes all the dependencies that are based in the dependencies manifest, and it's going to grab everything you need for that Lambda function to work, and then it's going to zip all of that up and push it out. Or if you're using a container image, it's going to create a local image and then push it to an Amazon ECR repository when you run SAM build or a SAM package later. Okay, so what have we done up until now? We've created our application, we've prepared our template to work across multiple environments, and we've learned how to build the application. So now our application is ready to go. So how do we deploy it? All we're going to do is go into the SAM CLI and run SAM deploy. SAM deploy deploys or updates serverless applications on the AWS cloud. It manages the S3 bucket for deployment artifacts. It saves all the deployment options to a configuration file. And then when it does deploy, it creates a CloudFormation change set. So all that's basically happening is you get a diff of what was there and what's there now. And so it compares the template to what's already out there. And then if it's a brand new deploy, it's just going to deploy it. If it's not a brand new deploy, then it only deploys the changes, or it'll kick it back if there's a problem and say, hey, this isn't going to work. So you can use SAM to deploy multiple environments, and we saw all the steps how to do this. Now we're going to see it in action. We're going to do a little bit of a demo here. And so what we're going to do is we're going to create this application, and in our scenario, anytime an item is added to a DynamoDB table, the invoked Lambda function is going to log the event in Amazon CloudWatch logs. So I'm actually going to do this from the serverless patterns collection. And so I'm gonna go to serverlessland.com/patterns and use one of our predefined SAM templates. So on the left-hand side, I'm gonna filter by DynamoDB because that's the pattern that I wanna use. And I'm gonna select this DynamoDB to Lambda pattern. And then I'm gonna click the download text to copy the commands to the clipboard. Next, I'm gonna go into my terminal. So once I paste the link from the download guide, I'm going to do SAM deploy guided, and all this is going to do is deploy my application. And just note that keeping the responses blank here is going to choose the default options that are displayed in the brackets. And this will take a few minutes, but you can see that our resources are being deployed. You'll see we have our Lambda function, we have the DynamoDB table, we have the role that's associated, the IAM role, and you can see that change set coming up here. So this is all coming from CloudFormation. It's taking the template that we just downloaded, and it's deploying those resources so that we have our application. So this just takes a few minutes to deploy. You can see it going through all of our resources. I could have made this shorter and cut it down, but I wanted you guys to get the full experience. Great, so now you can see once it's done, you get this success message that your stack has been created. So now we have all of our resources deployed. Now let's see it in action. Let's go test it out. So we're gonna head over to the DynamoDB console. So from the AWS console, we're gonna go to DynamoDB, click on tables, and then we're gonna select the newly created table that was created for us. We're gonna choose this table, and then we're gonna go to the items tab, and we're gonna choose create item. So we're gonna add a new item to this table. And we are going to name it whatever you want. So we're gonna add this new item. I'm going to name this, let's call this banana. So I'm going to insert a new item. There it goes. I'm going to insert a new item, make it a string, call it banana, and add this to our DynamoDB table. Great, so now we see this new item that's added to the table. So now we're going to go to the Lambda console. So from here, I'm going to head to the Lambda console. We're going to scroll down in the Lambda console. Let's just give it a second to load. There you are. So now we're going to choose our function, the function that was created for us in the SAM template, and we're going to scroll down to the Monitor tab, and then we're going to choose View Logs in CloudWatch. And so this is going to open our CloudWatch logs. And let's see where our message is. We're going to open the logs, and there it is. You see that we've added this new item to the table. You see this new image that's been inserted into the DynamoDB table. So anytime a new item is added to that DynamoDB table, this Lambda function is invoked and logs the event in Amazon CloudWatch logs. So again, you can see we have these predefined SAM templates in our serverless land patterns collection. So depending on the resources you want in your app, we have all of this infrastructure as code ready for you all to use. So again, we do have a ton of content and learning opportunities and patterns on our serverless land website. So if you scan this QR code, you can head over to serverlessland.com. We're constantly updating the site with new content, new learning opportunities, new patterns. So be sure to check us out on serverlessland.com. Thank you all so much for joining me in our journey through infrastructure as code. Again, my name is Talia. Thank you again. And please complete the session survey so that we can get some feedback from you all.